Imagine this. It's a crisp night in July 2025, and high in the Chilean Andes, a telescope named Atlas, designed to hunt for Earth-threatening asteroids, stumbles upon something utterly alien. Not a rock from our own cosmic backyard, but a wanderer from the void between stars, hurtling toward our sun at over 130,000 miles per hour. This isn't science fiction, it's the story of Comet 3I/ATLAS, the third confirmed interstellar object to grace our solar system. Discovered on July 1st, 2025 by the Asteroid Terrestrial Impact Last Alert System. It's a frozen relic from another star system, a messenger carrying secrets etched in ice and dust from billions of years ago. As it streaks through the darkness, trailing a faint coma of gas and dust, astronomers worldwide lean closer to their screens, hearts pounding with a mix of awe and trepidation. What tales does it whisper from the galaxy's edge? And why, in this moment of discovery, does it feel like the universe is knocking on our door, politely but insistently? Let's pause for a breath here, because this isn't just another comet zipping by like a shooting star at a summer barbecue. No, 3I/ATLAS is a cosmic time capsule, ejected from its home star system eons ago, drifting through the interstellar cold until gravity's gentle tug drew it into our neighborhood. Picture it formed perhaps 7 to 14 billion years ago in the Milky Way's ancient thick disk, where stars are older and metals scarcer. This icy body has outlived empires and extinctions on Earth. Its nucleus spans between 1,444 feet and 3.5 miles across, a colossal snowball laced with mysteries. And unlike the cigar-shaped enigma of Oumuamua or the more familiar Borisov, 3I/ATLAS is showing us a tale, a shimmering veil of sublimating ices that glows green against the lunar eclipse backdrop, captured in stunning detail by amateur astronomers like Michael Yeager and Gerald Riemann just weeks ago. As of September 19th, 2025, it's brightening faster than models predicted, surging in luminosity as it nears the sun's warmth, defying expectations and fueling late-night debates in observatories from Mauna Kea to Cerro Pachon. This visitor isn't just passing through, it's rewriting our story. In a universe of 100 billion stars, where trillions of rogue worlds and comets roam untethered, 3I/ATLAS reminds us we're not isolated. We're part of a grand, interconnected tapestry, where fragments from distant births collide with our reality. Feel that chill down your spine? That's the thrill of the unknown, the spark that ignited humanity's gaze skyward since the first cave dweller traced constellations on stone walls. So lean in with me. Let's unravel this thread by thread, from its blazing entry to the shadows it casts on our understanding of existence. And if a question bubbles up in your mind, does this change everything? Stick around. We'll chase that together. Transitioning from that electric moment of discovery, let's ground ourselves in the basics, because even the most profound mysteries start with the facts. Comet 3I/ATLAS, officially designated C/2025 N1A/TLAS, earned its 3I moniker as the third interstellar interloper confirmed by the Minor Planet Center on July 2nd, 2025. Pre-discovery images stretch back to June 14th, snapped by the Zwicky Transient Facility and Atlas scopes worldwide, painting a portrait of an object that slipped into our view unannounced. At detection, it was 420 million miles from the sun, just inside Jupiter's orbit, cruising at 58 kilometers per second relative to our star, faster than Oumuamua's 26 kilometers per second or Borisov's 32 kilometers per second, with an eccentricity of over 5, making its path a near straight hyperbolic arrow through space. No binding orbit here. It's a flyby, a cosmic hitchhiker slingshotting past without settling down. What makes it scream interstellar? Simple. Its velocity. To escape the sun's gravitational clutches at that distance, it needed excess speed from beyond, proof it's not a local drifter, but an exile from another system. Originating from Sagittarius, near the Milky Way's bulging heart, it dove in at a steep 90-degree angle to the galactic plane, bucking the drift of most matter and hinting at a violent ejection, perhaps from a fledgling star system's chaotic youth. By mid-September 2025, Hubble's July 21st snapshot revealed a teardrop cocoon of dust enveloping its nucleus, 277 million miles from Earth, while James Webb and SPHEREX peered deeper, mapping its spectral fingerprints. No danger to us. Its closest Earth approach is 1.8 astronomical units, or 170 million miles, in December 2025, but plenty of drama as it whips past Venus in late September, Mars in November, and Jupiter in January 2026, all on the Earth-facing side of the Sun for optimal viewing. Now, slow down with me for a second. Imagine holding a snowball from another world in your mind's eye. Cold, ancient, whispering of forgotten suns. That's 3I/ATLAS, an icy nucleus active even at 6.4 AU in May 2025, per TESS data, sublimating carbon dioxide into a coma before its official debut. Its tail, elongated to 3 arc seconds by early July, glows with the poetry of solar winds sculpting dust into ethereal streams. But beneath the beauty lies the science that tugs at our curiosity. Why is it brightening so aggressively now in mid-September, outpacing predictions by a factor that has modelers scrambling? As it hurtles inward, peaking at perihelion on October 29th, 2025, inside Mars's orbit, we brace for outbursts, sudden ejections of gas that could fragment it like Borisov did, or illuminate it to naked eye visibility under dark skies. This isn't passive observation, it's a race against the comet's fleeting visit, with telescopes from Gemini South to Lowell Discovery Telescope capturing every flicker. Shifting gears now, let's peel back the layers of this cosmic onion, starting with its chemistry, a cocktail that's equal parts familiar and freakish. Traditional comets, those loyal children of our sun, are water ice dominators, their tails blooming with H2O vapor as they bask in solar heat. Comets 101, right? But 3I/ATLAS flips the script. NASA's James Webb Space Telescope, in observations from August 2025, clocked a carbon dioxide to water ice ratio of 8:1, one of the highest ever recorded, with water barely a whisper in the spectral symphony. It's like stumbling on a desert oasis that's mostly dry sand, defying the hydration norms of icy wanderers. This imbalance suggests a birthplace in the cold outer reaches of another system, where CO2 froze first, locking away volatiles in a pristine, unaltered state for eons. Picture the scene. As 3I/ATLAS warms, CO2 sublimes voraciously, driving its unexpected early activity and that accelerating brightening in September of 2025. Spectrographs from the Canada-France-Hawaii telescope reveal marginal coma extensions, hints of a tail forming not from water's gentle boil, but CO2's explosive sigh. And the precision, that 8:1 ratio holds steady, fluctuating less than 0.02% over weeks of monitoring, a stability that's unnervingly clockwork for a natural process, which should wobble with distance and heat like a heartbeat under stress. Natural ices are messy, chaotic, they ebb and flow, yet here, it's as if the comet's composition is engineered for endurance, a relic so old, potentially the oldest we've ever probed, that it predates our galaxy's thin disk, carrying chemistry from the universe's toddler years. This isn't just odd, it's a window into exoplanetary nurseries we can't visit. CO2 dominance implies formation in shadowed zones, far from a parent star's glare, where water stayed gaseous while carbon locked into solids. Expand that thought. If 3I/ATLAS is typical, then rogue comets like it, trillion strong in the Milky Way, could pepper young systems with these volatiles, kickstarting atmospheres or oceans on worlds we dream of finding. Emotional resonance hits here, doesn't it? In its frozen heart, this comet embodies resilience. The survivor of gravitational tempests, stellar close calls, a September study tallies 25 within, 3.3 light years over 10 million years, now sharing its blueprint with us. But as telescopes like SphereX dissect its ices from August 7th to 15th, 2025, revealing thermal signatures alien to our solar system's palette, a quiet unease creeps in. What if this chemistry isn't just rare, but a clue to processes we've never imagined? Let's linger on that tension, because the trajectory ahead amplifies it tenfold. From chemistry's intimate whispers, we rocket outward to the grand ballet of 3I/ATLAS's path, a trajectory so improbably elegant it feels scripted by a cosmic choreographer. Most interstellar guests should saunter in along the galactic plane, riding the Milky Way's traffic lanes where matter clusters thick. But 3I/ATLAS, it plunged perpendicular, a 90-degree dive from above, energy inefficient for a natural ejectee, yet perfectly positioned for a scenic tour tour of our inner planets. Odds of this, astronomers peg it at 0.005%. Better luck shuffling a deck into perfect order than this random rock-threading Venus, 0.08 astronomical units in late September 2025. Mars, November, and Jupiter, January 2026, without a wobble. It's retrograde, swimming upstream against our solar system's flow, yet gravitational slingshots from these giants barely nudge it, maintaining a bullet-straight course that baffles planetary defense models. Visualize the drama. In September 2025, as autumn leaves turn on Earth, 3I/ATLAS ghosts Venus. Close enough for ground-based scopes to drink in details, far enough to evade disruption. November brings Mars into the frame, the red planet's thin air no match for the comet's velocity. By January 2026, Jupiter's massive pull tests the path, but Juno, NASA's orbiting sentinel, might snag a close-up, peering at a post-perihelion husk stripped of its CO2 cloak. And the timing. All flybys align with Earth on the sunward side, visible in our night sky. No far side occultation to hide the show. Coincidence? Perhaps. But string them together. The angle, the precision, the visibility, and patterns emerge, evoking that shiver of what if. Statisticians at JPL are rerunning simulations, their algorithms groaning under the improbability. At 61 kilometers per second inbound, accelerating to peaks near the sun, 3I/ATLAS should veer wildly post-flyby, yet projections show minimal deviation, as if it's weaving through raindrops unscathed. NASA's Psyche probe even brushed within 0.302 astronomical units on September 4th, 2025. A serendipitous encounter too risky for retasking, but ripe for passive data harvest. This path isn't just unlikely, it's a masterclass in solar system anatomy, surveying from outer giants to inner scorches. Emotionally, it stirs a sense of being watched, or chosen, in a galaxy teeming with such nomads. Models predict one lurking in our system at all times. Why this route for 3I/ATLAS? It challenges our randomness, hinting at hidden dynamics, stellar flybys sculpting paths over millennia, or something more. As it vanishes into solar glare post-September, re-emerging in December dimmer than magnitude 12, we ponder, is this luck, or the universe's subtle invitation to look closer? But wait, before we spiral into speculation, let's ground in the dust and glow, the tangible signs that 3I/ATLAS is alive with activity. High-res images from Hubble on July 21st, 2025 unveil not a random haze, but structured layers, an onion of dust particles defying solar radiation's pushback. Typical comets spew chaotic clouds, tails streaming like comet banners in the wind. Here, Gemini South's September 4th multi-band shots show geometric regularity, particles clustering at 10,000 kilometers out, mimicking self-assembly rather than scatter. Some even drift counter to expected pressure, as if buoyed by unseen fields or intrinsic motion, a puzzle that has JWST teams cross-checking data late into the night. Then, the temperature anomaly. At 3.8 astronomical units in August 2025, models predict negative 100 degrees Celsius, yet readings hover at a balmy negative 23 degrees Celsius, 250 Kelvin, steady as a heartbeat. Internal heat? Exotic albedo reflecting sunlight in bizarre ways. Green Bank telescope engineers, monitoring faint radio whispers, dismiss instrument glitches but note structured signals. Patterns not matching natural spectra, faint echoes from the comet's direction. No one's crying ET phone home, but the data nags. Why the clockwork? Why the order in chaos? This is where storytelling meets science's edge. The dust isn't just debris, it's a canvas. Noir Lab's recent images capture the tail's green glow during the September lunar eclipse, a visual symphony of ions dancing under solar wind. Emotional pull? It's the fragility, a 3.5-mile behemoth, yet delicate, potentially fragmenting at perihelion like a cosmic sandcastle against the tide. As it sheds layers, we glimpse not destruction, but revelation, exposing a core that could harbor prebiotic organics, the building blocks splashed across young Earths. In this dance of dust, 3I/ATLAS teaches impermanence, urging us to cherish the now. But as patterns persist, from layered ejecta to thermal defiance, the narrative quickens. Are we witnessing nature's wild card, or a glimpse of the engineered unknown? Diving deeper into the heart of the enigma, let's confront the whispers that don't make headlines. The ones exchanged in observatory hallways, over lukewarm coffee at 3 a.m. Radio monitoring from 3 stations, including Green Bank, has picked up faint, structured emissions since August 2025. Patterns too ordered for cosmic noise, but too subtle for bold claims. Instrument anomalies? That's the line, but with multiple confirmations, it's fraying. Meanwhile, dust layers from JWST high-res imaging suggest manipulation, localized fields bending particles against physics grain, evoking magnetic bubbles or self-propulsion we can't yet model. Behind closed doors, astronomers grapple with stability that screams artifice. That CO2 ratio's 0.02% variance. Natural processes fluctuate. This holds like a machine tolerance. Temperature at 250 Kelvin, unwavering. Thermodynamics in vacuum demands variation. Here, it's constant, implying internal regulation or absorption tricks beyond our ken. And the trajectory's 0.005% odds. Statisticians liken it to winning the lottery while blindfolded. Yet it threads planets with surgical grace, visible always from Earth. Whispers grow. Is this the luckiest rock in history, or a probe charting us? No panic in press releases. NASA's measured tone speaks of unusual but natural, echoing past dismissals. But insiders, from UCLA's David Jewett to Northeastern's Jacqueline McCleary, admit the discomfort. Data points to revolution, yet caution reigns, lest one be the fool shouting aliens. History nods. Oumuamua's acceleration sparked wild theories, only for natural explanations to prevail. Still, Avi Loeb's August Arcshiv paper ventures there, citing size, chemistry, and path as tantalizing for technosignatures. Artifacts of advanced tech, dormant until activated. NASA debunks swiftly. It's a comet, tail and all. Yet the debate simmers, a human drama of fear and hope. Emotionally, these whispers evoke isolation's ache. Are we alone in our curiosity? Or watched? It tests our humility, urging open minds amid rigorous proof. As 3I/ATLAS nears perihelion, will outbursts reveal more, or silence the speculation? The tension builds, drawing us onward. To truly appreciate 3I/ATLAS's oddity, we must zoom out to its siblings, the interstellar family tree with just 2 prior branches. First came 1I/Oumuamua in 2017, a reddish, tumbling cigar 800 feet long, discovered by Canadian Robert Warwick via Pan-STARRS. No coma, no tail, just anomalous non-gravitational acceleration, later pinned on hydrogen outgassing, but not before Loeb dubbed it a light sail. Then 2I/Borisov in 2019, a more cometary cousin with a cyan-tinged tail, rich in water and organics, fragmenting spectacularly, our first clear peek at alien chemistry. 3I/ATLAS eclipses both. Faster, larger, CO2 heavy, with a path that's a precision tour de force. Where Oumuamua hit its heart, Atlas bears a tail. Where Borisov mirrored our comets, Atlas diverges with its ice ratio and thermal poise. It's the fullest portrait yet, thanks to 2025's toolkit. Webb, Hubble, Sphere-X, TESS, all converging like a stellar all-star game. Yet rarity bites. With Vera C. Rubin Observatory online this summer, we expect 1 to 2 per year soon, but for now, each is a lottery win. This lineage stirs legacy's weight. Each visitor builds on the last, refining our galactic census. Oumuamua taught detection, Borisov composition, ATLAS extremes. Together they paint a Milky Way alive with ejecta, trillions of nomads implying frequent visits, one always nearby per models. Emotionally, it's connective tissue. We're not anomalies, we're hosts in a bustling cosmos. But as Atlas outshines its kin in strangeness, it begs, are these harbingers of normalcy, or outliers hinting at more? Peering further back, history's archives brim with ghosts, unconfirmed sightings that echo 3I/ATLAS's profile. The Great Comet of 1844 baffled observers with retrograde wobbles, its path too straight for solar binding, logged in dusty ledgers now digitized. Song Dynasty Chinese records from 960 to 1279 AD describe guest stars defying heaven's spin, retrograde wanderers akin to Atlas's upstream swim. Medieval Islamic astronomers chronicled wandering lights off planetary rails, while Galileo's 1610 notes hint at fleeting bodies too swift for comets. These weren't errors. Pre-telescope eyes caught what tech now confirms. Pan-STARRS and Neowise have flagged dozens more, faint fast transients filtered for lack of follow-up, but insiders whisper our system hosts far more than 3. Military radars occasionally snag ultra-fast blips, vanishing before verification, classified whispers of visitors too nimble for pursuit. 3I/ATLAS isn't exceptional. It's detectable, large, active, timed for our era's gaze. This historical tapestry evokes destiny's thread. Humanity, from Babylonian star charts to AI-driven scopes, evolves to decode these messengers. Emotion surges, pride in our progress, humility before the overlooked. If ancients glimpsed shadows, we grasp the form. Atlas bridges eras, urging, how many have passed unseen, shaping our world in silence? From history's hush to imagination's fire, where does 3I/ATLAS fit in our quest for others? Astronomy thrives on bold leaps, rings around planets, black holes' maws, exoplanets' hordes, all dreamed before proven. Enter Bracewell probes. Ronald Bracewell's 1960 vision of dormant sentinels, awakening to scout habitable zones, lingering millennia for contact. Atlas ticks boxes, intentional path, material stability, energy anomalies, yet Loeb speculation draws NASA's rebuke, natural, with a tail proving it. Techno-signatures evolve SETI beyond radio hunts, seeking persistent artifacts, Dyson swarms, engineered ejecta. Atlas's CO2 precision, dust order, radio hints, they prod expansion, even if mundane. Arrogance dismisses, humility explores. The emotional core, wonder as test. Atlas isn't proof, it's provocation, mirroring our intellectual mirror, dismissal or curiosity, dogma or flexibility. In its passage, we confront ourselves, hearts alight with possibility. Now let's stretch our perspective to the galactic scale, where 3I/ATLAS emerges not as an anomaly, but as a fleeting ambassador in a cosmos teeming with wanderers. The Milky Way, with its 100 to 200 billion stars, churns out rogue objects like a cosmic factory. Planets, comets, asteroids ejected during stellar adolescence, or cataclysmic events like supernovae. Models suggest 10 to the 15th such nomads roam interstellar space, a number so vast it dwarfs comprehension, each potentially carrying clues to its birthplace's chemistry, dynamics, and history. 3I/ATLAS, with its CO2 heavy ices and ancient origins, might hail from a star-forming region in the Milky Way's thick disk, where low metallicity stars forged leaner, icier bodies than our sun's brood. Its journey, spanning billions of years, likely saw close encounters with other stars, 25 within 3.3 light years over 10 million years per recent simulations, each gravitational nudge sculpting its path toward our solar system. Emotionally, this evokes a profound sense of continuity. 3I/ATLAS isn't alone. It's a single note in a galactic symphony, connecting us to unseen worlds. As it passes, we're not just observers, but participants in a story older than Earth, where every interstellar visitor whispers of shared origins and the restless churn of creation. Consider the technological marvels enabling this glimpse. In 2025, humanity's arsenal, Webb's infrared precision, Hubble's visible clarity, SpherX's spectral maps, TESS's vigilant scans, converges to dissect 3I/ATLAS like never before. Unlike Oumuamua's fleeting 2017 cameo caught late with limited data, or Borisov's 2019 fragmentation, Atlas benefits from a global telescope network primed for transients. The Vera C. Rubin Observatory, freshly operational in Chile, promises to spot 1 to 2 such objects annually, revolutionizing our census of interstellar guests. Amateur astronomers too join the fray, their backyard scopes capturing 3I/ATLAS's green tail during September's lunar eclipse, democratizing discovery. This synergy stirs pride. From Galileo's crude lenses to AI-driven observatories, we've built tools to touch the stars. Yet, it humbles us. Each advance reveals how little we grasp. 3I/ATLAS's anomalies, structured dust, stable temperatures, faint radio patterns, push our instruments to their limits, hinting at physics or processes just beyond reach. The emotional tug, it's the thrill of standing on discovery's edge, where every data point is a step toward rewriting textbooks or confronting the unknown. As 3I/ATLAS approaches its October 29th, 2025 perihelion, the narrative crescendos toward a climax of possibility. Will it fracture like Borisov, scattering fragments that reveal its core, or endure, its CO2 coma blazing brighter, perhaps visible to the unaided eye in dark skies? The Comet Interceptor mission, set for 2029, waits in the wings, designed to chase such transients. But 3I/ATLAS is our moment. Our chance to probe a relic before it exits toward infinity. Its legacy will linger, insights into galactic chemistry, planet formation, the seeding of life. But more, it's a mirror to our curiosity, reflecting our drive to ask why against the void's silence. Emotionally, it's a call to action, not just for scientists, but for us all, to look up, question, and connect. As it fades post-December, dimmer than magnitude 12, we're left with a choice. Cling to the familiar or embrace the cosmic unknown. So what stirs in you? A comet's tail or a cosmic call? Share below. Your thoughts fuel this shared journey. Like if it sparked awe, comment your theory, subscribe for updates. Finally, let's hold 3I/ATLAS as a mirror to humanity itself, reflecting our dreams, fears, and the eternal tension between caution and courage. This comet's passage isn't just a scientific event, it's a cultural moment, a test of how we confront the unknown. The whispers of techno-signatures, sparked by Avi Loeb's bold hypotheses, clash with NASA's measured insistence on natural explanations, echoing a deeper human struggle. Do we dare imagine beyond our paradigms, or do we cling to the safety of the known? 3I/ATLAS, with its clockwork CO2 ratio, its improbable trajectory, its dust that dances against physics, challenges us to balance skepticism with openness. It recalls historical leaps, when Galileo's telescope upended geocentrism, when exoplanets moved from fiction to fact, where imagination preceded proof. In its green-tinged tail, glowing against the September 2025 eclipse, we see not just ice, but possibility. What if it carries organic molecules, precursors to life, linking our Earth to distant worlds? What if its path, so perfectly aligned for our telescopes, is no accident but a cosmic signal, however faint? The emotional resonance is profound. It's the ache of longing to know our place, the thrill of standing at a crossroads where science and wonder intertwine. As 3I/ATLAS nears its solar climax, potentially fragmenting or blazing brighter, it invites us to act, to share our theories, to debate its nature, to look up and claim our role in this cosmic narrative. Its legacy will endure, not just in data, but in the spark it ignites, urging us to keep watching, keep questioning, keep reaching for the stars that birthed us all.